Yeah. Okay. Omi can start this introduction.
All right. Good morning, everyone. My name is Vistro. I'm the director of PTV in Asia Pacific. First, I'd like to thank Tim and TMS team for organizing this event and inviting us. I'd also like to thank my friend Dr. Shu. I hope he's there for his continuous kind support as every year. And I'd like to apologize for not being able to be in Taipei in person this year, like the previous years. I've been there last 3 years, I believe, and I would have very much liked to be in Taipei this year, but as you know, coronavirus has changed everything this year, and we have all been forced to adjust our lives, and that is one consequence of it, that I'm not able to travel. There is obviously a human aspect of this epidemic, and sadly also loss of lives in many parts of the world, which is very unfortunate. But there has also been a deep economic impact, which has affected people greatly around the world. This impact has been different in different countries. For example, in Melbourne, where I live, we have been all locked down. We can only leave the house for necessities of life, and even evenings we cannot leave at all. So we are under curfew after 8 o'clock at night, which is very restrictive. As a result, it has affected the economy, and earlier this week, Australian government announced a 7% drop in overall economy in Australia, which has been unprecedented. I'm hearing that in Taiwan, the government has handled the situation much better, in fact, very nicely, and your lives are no longer as affected, at least, as lives of Australians. Obviously, there is still some effects, and everyone is worried that there will be a second wave, a third wave, but in any case, what I'm hearing about Taiwan is that your life is getting back more and more to normal. However, worldwide, experts expect a reduction of consumer spending by 40 to 50%, and as a result, a 10% drop in GDP. Transport also as an industry has been hit very hard by COVID, and here are some examples I'd like to share with you. This year we had 90% less car production worldwide. Public transport has been, and public transport ridership has been hit very hard and has dropped in average around the world. In big cities, 70 to 90%, which is huge. And there is also a 60 to 70% reduction in ride-hailing. What the longer-term effects of these changes are still unknown, and we have to wait and see what is going to happen and what the effect of this virus is going to be in near future or even long term. But one important factor that is going to influence the direction of where we are heading to is the regulatory decisions that many governments around the world are going to make. These decisions will most likely be different in different countries. Some might view this crisis as a turning point to accelerate the transition towards sustainable mobility. We all know that the industry has been talking about that and the move towards sustainable mobility, and this might be the turning point for many governments to enforce that. Others, however, may loosen up the rules to support the weakening economies. In some countries, you may see cash incentives for trading in old cars. For example, for electrical vehicles, we see that in Europe, in some parts of Europe. In other countries, On the other hand, we may see a relaxation of emission rules, for example. Again, because of the issues that economies have with coronavirus. In light of social distancing, some regulators may relax private mobility, and others may focus on creating more space for pedestrian and cyclists because they like to see that this is a safer mode for people to move and to travel. But aside from governments, we also will see different responses by the industry. Some OEMs and car manufacturers have already delayed some investments in development of advanced technologies in the area of autonomous vehicles. At the same time, we see also increased investment in electrical vehicles. So we see both of them, and that's an interesting trend to be watched. And finally, we will see different choices of consumers and potentially a change of consumer behavior in transport industry. Some will increasingly use private car because of the safety, because of the social distancing issues, and because public transport may not be perceived as safe as before. Some will switch to other modes, such as biking or walking. And also, we may see that remote working becomes more and more a trend around the world, which obviously is going to impact at least the need for transport. Now, the combination of these influencing factors I just briefly mentioned will shape the industry and the world of transport in the years to come. Now, we at PTV, of course, are continuously following these developments to determine the best strategy to respond to future trends. And today we have prepared some presentations to share with you some of our thoughts and what our R&D and development team has been working on. To do that, we have some of our best minds in Asia Pacific here today. And if you allow me, I'd like to briefly introduce them. Even though she is not here today this morning with us, but she will join us. Yang Yao doesn't need any introduction, I believe. She has been our area manager in Taiwan for some years and has been working closely with our partners, with Tim and TMS, and also I'm sure many of you have already met her, and I'm not going to introduce her. Long, you already know her very well. Summer is responsible for marketing in Asia Pacific and making sure, and she's based in Singapore, but is responsible for Asia Pacific and making sure that you everywhere in Taiwan, but also the rest of Asia Pacific, are always informed of latest development at PTV and any news that we can share with you. David is our Managing Director of Australian Operations and is going to talk about a very interesting project on electric charging, electrical vehicle charging that our colleagues in fact in UK have developed, but we believe is relevant around the world and in other regions, and therefore we'd like to share that with you, and I'm sure you're going to enjoy his presentation. Later, our solution specialist team, Gobi and Min, are going to introduce some of the exciting new features that will be released shortly in the next version of Visum, Vissim, Viswalk, and Vistro. And as we have many users today with us, and I'm sure you're going to be very interested in finding out what those features are that our development team in Germany has been working on. And last but not least, this afternoon, Moto, our colleague from our Japan office, from our Tokyo office to be exact, is going to talk about how Vissim can be used for testing CAD environments, and he has a lot of experience in this field working with OEMs I should say Japanese OEM, obviously in Japan. With that, And once again, I'd like to thank you for having us, and I hope that very soon I can meet all of you again in person in Taipei. Thank you very much.
Thank you, Omi. Okay, so Simon, you can start your presentation, the PTV side.
Okay, so can all of you hear me properly?
Yes.
Okay, perfect. I'm just going to switch off my video just to make sure we have enough bandwidth for my presentation. Right. Okay. Thank you, Lee, for the introduction. Let me share my screen. Okay, let me know once you can see my screen. Are you able to see my screen?
Yes, we can.
Yeah, we can.
Yes.
Okay, perfect. Okay. Yeah, thank you very much for this introduction. And I'm going to present a project that we have been working on in the UK. So this is a very nice follow-up on Omi's comments about sustainability and also the emergence of AVs and electric vehicles. So this is quite an unusual or innovative use case for Visum applications. So the name of the project is called Charge Project, which is basically modeling electricity demand for electric vehicles or EVs in the UK. First of all, I'm going to give you some background of this project, and then I'll talk about the objectives and the purposes and what we're trying to achieve with this project. And I'll go into a little bit more detail about the modeling work that we have been working on for this project. Not the usual 4-step trip-based demand model. Instead, it's a tool-based demand model on Visum platform. And then I'll talk about some of the innovation steps that we have undertaken for this project. First of all, some news clippings. So, as we mentioned, the popularity of EVs is growing, not just in the UK, but also around the world. And these changes are actually coming from two sides. So, there have been pushes from the government, and also there are market forces in it as well. So, there are legislative pushes from government all around the world to encourage EVs. For example, in the UK, they're planning to ban diesel and petrol cars sale by year 2035. Similar pushes from other governments as well around the world. And then on the other side, there are market forces as well. So the demand is increasing for EVs because of climate consideration. Also, the costs are continuing to fall. So now for a new EV vehicle, the price is almost at parity to your conventional vehicles. Also, the ranges are increasing and the charging times are decreasing. So all these are important factors which are at play leading to the popularity of EVs. So there's definitely climate benefits when it comes to EVs. Climate potentials of EVs to improve as the electricity grid continues to decarbonize. EVs is twice as efficient in terms of emission when we compare to diesel vehicles. At the same time, this is in the UK, transport industry has now actually overtaken energy industry as the most polluting industry. So this provides, or this encourages further pushes for EVs into the market. So with the popularity of EVs increasing, the next obvious question is in the grid core. So with large increases in electricity demand expected over the coming years, this is not going to be happening overnight. The EV charging is actually quite substantial. So one EV is being charged at home can actually double a household's electricity demand. However, in all likelihood, there will be enough generation to meet the demand. So just like transport, where we have peak outflows, non-peak outflows, just like transport, the pinch points for energy demand will arise in the supply network, what's called the distribution network, such as cables, overhead wires, supplying electricity from power stations, wind farm, etc., to individual households. So it's important for distribution network operators to anticipate where and when this demand is going to be, which will then impact on the local grid. So this is basically the motivation of this project. So the project is called Charge Project. So there's a website to it. So if you want to find out more about it, you can visit the website. So there are three partners involved in this project. SP Energy Networks, which is the energy supplier, and they are the client for this project. PTV Group is in charge of developing the model to determine the energy demand for EV charging. We also have Smarter Grid Solutions, which is responsible for charging technology, and also we have EA technology, which is coming from the electricity sector. So charge project objectives, they include anticipating how much, where, and when electricity will be required so that infrastructure reinforcement can be done properly. Also, the project is to develop systems to manage the peaks and troughs through smart charging. As I mentioned before, the electricity demand will not be constant throughout the whole day. So we need to find a smart way to manage the demand, just like transport demand. Also, we're trying to make it easier for charge points to be installed. So the model will be used to identify the suitable locations for charging points. So there are some innovation steps that we have undertaken as part of this project. First of all, we have built a tool-based demand model. So this is somewhat different from the normal standard four-step trip-based demand model. So the tool-based demand model, we are modeling tools of different activities by different person groups throughout the whole day. So it's a 24-hour model. So let's take you as an example. So maybe your tour will start from home in the morning, and then you get into a business activity, coming to this event. So from home to business, and then maybe after the event, you may go back to the office to work. So from home to business, and then to work activity, and then back to home after you finish work. So home, business, work, home. So that will form one tour. So basically, we're modeling different tours with different activity chains, different person groups, as part of this tool-based demand model. So I'll talk a little bit more about the tool-based demand model later on in the future slides. Also, we have developed detailed scenario plans for many different parameters, EV updates, and some other defining parameters. Relating back to the first point, we make use of path sequences to create individual schedules and also to infer charging patterns. We have also made use of the optimization tool that we built in-house, PTV, to identify critical locations for on-route charges. So basically, we built a tool-based model to cover SP network. And this will be used to anticipate where, when, and how much charging is likely to take place up to year 2050. So this will help SP network plan upgrades or mitigation strategies to handle the additional electricity demand. So that's the study area of our model. So you can see it covers the entire UK territory. So the blue area is our core area. That's basically where SP network operates. So there's an area around Liverpool and the northern and middle part of Wales. And then we have an intermediate area which is shaded in green. So basically that acts as a buffer from the core area, the outer area, which is shaded in red. So basically we have included the entire UK in the model because it's important for us to consider not only the
internal trips within the core area, but also the external trips between the core and the outer areas. Okay, a little bit about the tool-based demand models. So first of all, we have the entire population, and we need to subdivide the population into various person groups to represent the differences in likely travel behaviors. So for the purpose of the transport model, person groups correspond to homogeneous segments of the population whose travel patterns are defined by fixed parameters and distributions. So you can see all of these are all the different classifications. So they include the area type of the home zone. So you can see a home can either be classified to be in a rural area or an urban area. Person's economic status, so whether that person is economically inactive or active, as in employed, or the person is a student or under 16, their car availability, so whether that person could has access to a car or not, also their income level, high, low, and medium. So after defining the person groups, we will need to define activities. So activities within the model correspond to the purpose of travel and the activity that is being undertaken at the destination. So these are all the different activities defined in the model. So we have home, work, business, when employees are going up for meetings, attending to this event, education, going to universities, going to schools, shopping, and several other activity purposes. Then we have defined tool types. So we have defined more than 5 tool types. These are just the top 5 tool types that we have in the model. So travel choices in the charge model are defined by the sequence of activities that are undertaken by each person group throughout the day. So each activity set for tool type has been specified using the data from the UK National Travel Survey, the most popular tools being used in this model. So all up, we have 30 tool types. So the most popular one being from home, going to other activity, and then back to home. So that accounts for almost 1/3 of all the tool types, of all the trips. The second most popular one would be from home, going to work, and then back to home. That accounts for about 20% of all the trips. And then we have home education home, and then home shopping home, and then with 2 other activities, and then back to home. So with the tool-based demand model, there is a destination choice and also a mode choice step. So after these 2 steps, destination choice and mode choice steps, we can then determine the trip length. So you can see that the most popular trip length is somewhere between 3 and 5 kilometers. And the most popular one is somewhere between 5 and 10 kilometers. So it is important for us to consider trip length because for the charge project, the trip length information will then be used to calculate the amount of energy that is consumed per EV trip. The charge model is a 24-hour model, so it's able to represent 24 hours of a typical weekday. So what we need to do is to break that demand down to the hour. So within the day, the demand is distributed at an hourly level based on the travel time profiles from the National Travel Survey again. So as you can expect, there's a surge in demand around 8 a.m. in the morning, and there's another surge at about 4 p.m. So that's when most of the workers are going to work and are leaving work. So this information will be used to determine when and where the charging is likely to take place. Combined with the known trip distances from these journeys, we can then calculate how much energy might be required for charging at different locations at different times. A little bit about the road network in the model. So you can see we have a very, very detailed, precise road network defined in the model. So within the core area, which is shaded in gray on the left, we got the road network from a commercial data provider on top. They provide very, very high quality, detailed road network. So we can just make use of that. And also, I'll mention here as well. So we have a working relationship with TomTom, so we actually can get the TomTom road network download in Visum format. So that makes it very easy for us to do more work. For the external area, we got the road network from a legacy model that was done by PTV before. So yeah, so we have established the basic model, and we have calibrated the basic model using guidelines based on data coming from a variety of sources: mobile phones, surveys, current locations. On the right-hand side, you can see some of the statistics of this basic model. So within the core area, there are 6 million people within the core area. And then throughout one day, within the core area, there are 7.5 million cartridges within the core area in one day. So 7.5 million cartridges. So that accounts for 61% of all modes in the core area. After establishing the basic model, we can then go on to establish our scenarios. So for the charge project, the way we plan scenarios are slightly different from the usual standard transportation planning project. So for your transportation planning project, you will have one future scenario, and then you may undertake some sensitivity test, maybe plus or minus 10% of that future scenario. But with the charge model, there's so many different parameters, so many factors that we need to consider. So the way we come up with the scenarios is slightly different. So we held a workshop. I've invited different stakeholders to participate in the workshop to basically discuss all the different parameters to establish our scenarios. So this workshop proved to be a very, very useful exercise because first of all, we get participation from all the stakeholders, and at the same time, customers felt that they have been included in the development of this model, so they feel part of it in the development of the model. So just a word cloud of some of the parameters that have been discussed in the workshop. So you see things like EV supply, the level of public charging, the purchase costs, battery technology, and many other parameters that were discussed. So at the end of the workshop, we decided there are 2 main parameters to be considered. The level of the EV uptake rate, and also the level of public charging landscape. So, based on these 2 parameters, we come up with 4 different scenarios. Okay. The most optimistic one, which is on the top right quadrant, with high EV uptake and also with open and plentiful charging infrastructure availability. So that's the scenario with one cost for net zero, or scenario A. So that's the most optimistic scenario. And then on the other end of the spectrum, we have a scenario with slow progress. So that's with very, very low EV uptake, and at the same time, private and very patchy charging infrastructure availability. And then between these 2 extremes, we have 2 middle scenarios to be considered as well. So all these scenarios are actually quite plausible. It really depends on, on the policies, depends on the government pushes, it depends on how the technologies are evolving, it depends on the economic climate as well. So there are many factors in play so all these scenarios are plausible. So I would like to show you some outputs of the model for these scenarios. So there's the most optimistic scenario, scenario A with net zero emission. So you can see that with this scenario, the EV proportions are actually quite high in some areas. So those are the areas around Liverpool. But to the west of the core area, you can see that the EV proportions are still quite low. But bear in mind, this is quite a large area, sparsely populated. So this is a very rural area in the northern and middle part of Wales. Now, if you look at the other extreme, scenario D with slow progress. So with the low EV uptake with very patchy charging infrastructure in place, you can see the EV proportions are uniformly low. So we don't actually have any area with an EV proportion of higher than 10% by the mid 2025. If we go back to the first scenario, based on the model outputs, based on the tours, based on the EV's proportions, we are able to derive different types of EV charging demand. So you can see the charging demand in bar charts, and also color-coded based on the different types. So you can see residential off-street charging demand in blue. So these are the demands with the population charging the EVs in their own garages. We also have residential on-street charging in purple, public charging in green, and also workplace charging in red. So this information is quite important for which help the SP network to plan their energy strategies in the future. Next step. So this is still an ongoing project. We haven't finished it yet, but we have already developed the future year models and also applied the scenario assumptions. We've also manipulated the path sequence outputs. We've also defined different parameters, different scenarios. So our next step would be to refine the model results in collaboration with our client. Also, we're going to use our own optimization tool to identify the key locations for on-route charging points. Also, we're going to disseminate the results of the model via an online tool, which is called Connect More. So this tool will be able to help investors decide on the key locations for the infrastructure development. So that's a very, very quick summary and update of where we are up to with this project. So it's still ongoing. So please keep in touch if you want to have further updates on this project. And so this is a project conducted by PTV UK. So I would like to credit our UK team for conducting this innovative project. So yeah, so it's a very innovative project. You know, normally we don't use transport model for to determine the electricity demand. So this is a very, very new use case, which opens up a lot of markets for us. So yeah, please keep in touch. This is my email address. Thank you very much for your attention.
那个各位来宾，如果就是坐比较后面的，可能看不到简报的话，我们那个纸袋里面有附一张蓝色的纸，它可以去扫描那个简报下载，然后这样看的话可能会比较方便，因为可能后面的人会稍微看不到比较小的字体，再麻烦大家，谢谢。Okay, Sandra, we can go on.
Okay, next up we will have Gobi. Gobi, please.
Yes. Okay, just a sec. Let me share my screen. So, someone can you see me?
Yes.
Okay. Okay. Good morning. I'm Gobi. Would like to present, like what is the new features which, like in PTV Visum 2021, and what, I'm going to showcase is the first part is the new features in Visum 2021, and the second part is the new features in PTV Vistro 2021. So let me start my presentation. So, as per the chronology, okay, with the PTV Visum development. So for Visum 2021, the focus is more on public transport, multimodality, which is which David focus on the e-vehicles, and the scenario management for the public transport. So what are the new features which has been introduced or has been improved in PTV Visum 2021 is crowding in public transport, ride sharing with e-vehicles, intermodal assignment, and auto demand calibration. So the second part of this is, what are the improvement which PTV made in Visum for visualization. So let me take you through for the procedures. Okay, the first improvement which PTV has made for Visum 2021, it's a timetable-based capacity constraint assignment. So right now, as what as we know, for the timetable base, okay, public transport is not really, it's not a constraint of whether how many people are boarding, the capacity of the public transport. So in this case, crowding in public transport become more and more a problem. I think most of traffic modelers who involved in public transport traffic modeling, this, the main question is, how if, let's say, if there's the bus or train is run on a full capacity, so what will happen to the remaining passenger? So PTV has took this feedback and we have improved these features. So in this case, more people are using public transport and to achieve but the infrastructure can't handle more supply. The Visum already depicts crowding in vehicles, means the discomfort not to find a seat or a squeeze in a full train is reflected in a higher perceived travel time. But the new functional piece, okay, depicts the circumstances where the trains are or vehicles are that full passenger fail to board. So the capacity of vehicle can't be exceeded and the passenger have to search for alternative route at the station. So in this case, with the new features, the capacity volume indicates that the discomfort of vehicle journey item, the time using this journey is perceived longer. And the impedance to use this journey is higher and every passenger is served. Even the capacity is exceeded. So this is the current status of public transport assignment. With the new features that the vehicle have a maximum limit of occupancy. Passenger who wants to board a full vehicle fail to board. Passenger have to do a search and an alternative connection starting from their stop and time. If no alternative is found, the passenger are stranded. So this with these new features that we can find out what is the actual delay at the platform or number of people who are stranded at the platform. So what is the procedure? How we can run this procedure in Visum? So in this case, the procedure is, I think with some of you are with the transport experience, public transport modeling experience in using Visum. So the procedure is, first we use timetable-based assignment, derive volume at vehicles, journey item, and the second step is journey items are sorted by starting time, and the third, the volume of the boarding and transferring passenger on the first overcrowded vehicle item will be reduced to the maximum capacity. So that all connection will be affected equally. The cutoff connection will start a search of alternative routes at the given stop time plus 1 second. Extra search parameters rounding are applied to reduce the number of alternatives. Then the last step, the alternative connection will be connected to the cutoff planned connection. Those connections will be marked. So in this case, as what you see on my right side of the screen, so I've put some example. So where if let's say the passenger, okay, if they find in the green line, the capacity of green line is sufficient. So 20% of 40 boarding passenger here experience a delay of 20 minutes. In the end, due to insufficient supply. If the capacity on the green line, would have been not sufficient, people again fail to board on the train. So they have to, consider as, Visum will consider as they are stranded. So from this capacity constraint assignment, fail to board, what are the outputs which we can get, which Visum will produce? Okay, first, the connection marked with the number of planes. Number and share of passenger fail to board per journey item. In addition, fail to board without alternative. The third output which we can get is risk of fail to board. Calculate the risk delay at the end of the connection. So, for example, 5 plus 15 10. So, it roughly gives you, what is the average delay. And the fourth output which we can get is number or share of passenger fail to board and stop. And the last one is scheme matrix of delay or fail to board. So you can convert all the delay for a corridor or public transport corridor into a matrix format. So then the second features in Visum, which for Visum 2021 is dispatching a ride-sharing fleet with e-vehicles. So these features, okay, we have put in two main sub-features, which is limited range and long-lasting charging. So limited range, okay, so where these are the range which we can be included to make the dispatching ride-sharing more efficient. So battery electric vehicle, define ranges, conservative strategy, calculate longest distance to recharging station in network for buffer, at minimum charging threshold, return to charging facility, and recharging is priority. So no trips are served. And the second features which has been added is long-lasting charging. So that now the user can define charging time, and at the same time they can define always complete charging cycle. So these two features will improve how this e-vehicle operation in a Visum platform. So goal of the holding area. So with the e-vehicles, more optimal routing. When there's an inactivity during the tour, vehicle will reroute to chosen central location to wait for the next request. So then, but may accept a new call while relocating. Trip requests do have a priority. So also ensure the vehicle start at predefined location in the network. Previously, the vehicle randomly showed up at the first peak location. So this is for the ride sharing improvement, which which you see or you can use in Visum 2021. So then the next ride sharing ride sharing features improve in Visum 2021 is the intermodal assignment. So for intermodal assignment, just on the side, let me here you see the workflow of intermodal assignment. The crucial point is that for the route search and route choice, we need travel times of ride sharing links. There's no formula which gives us the value. So we perform a tour planning simulation and derive the travel times from the experienced travel times. To add some stability, what we do, we aggregate the experienced detour factor of all realized trips inside a certain main zone relation. Then the second step is we apply these average detour factors to the ride sharing links. So in my right side of the screenshot, so this is the PUT path links which you can define, and perform a new route search or route choice using the updated travel times. So this goes around many iterations and takes some time. So there's a multi-iteration required, and at the end, we have a well-converged detour factor, but we restart the assignment, we could not use that as the initial value. The point is, the first search, for the ride sharing in PT intermodal assignment, intermodal assignment between private vehicle and public transport. Okay, so improvement which for the intermodal assignment which has been done faster, so up to factor 2, more stable and faster convergence, a warm start. So this is how the intermodal assignment works. So if you look at this, the intermodal assignment workflow, the macroscopic and the microscopic. So the macroscopic is more of the route search, route choice, then the split route. Then after that it goes more detailed. So more detail to the microscopic level where generate trips are request, and then after that Visum will do the pro planning. Once this has been calculated, this will be passed back to the route search. So at the same time, before the tour plan is calculated, the result will be aggregated before it passed to the macroscopic. And this is how it looks like, when in the matrix format. So the result analysis, so you will see, the DRT demand, so demand response, transport demand, and the waiting time. So how long, for the ride sharing vehicle has to, wait. Same time, what is the, the demand for the ride sharing vehicle. So in case if you don't plan, the DRT without tour planning. So, it's just between, the route search and route choice. So the third features which have been improved is auto demand calibration tool. So we all know that for demand calibration tool, if model and reality have a different model split. So this tool, it's useful to analyze reason for the different. So person group in segmentation inappropriate or different behavior in different area. Extend the model accordingly. As always remains a certain data that cannot be solved. So sometimes manual calibration is extremely time consuming. So in Visum 2021, PTV has included a demand calibration preparation. For this situation, okay, so this demand calibration preparation actually is a built-in function which you can find in Visum add-in, which automatically calibrate the demand model. Yeah. So in here, I would just like to show that that what with this new features that it can do more than one demand segment. So at the same time, so you can calculate the average, average, what is the model calculated work trip, education trip, shopping, leisure, and home. So this function can take it to the next group. Okay, it can further disaggregate. Okay, it can go takes to a person group as well. Let's say for people, the student. So student with car, student without car, then employment with car, employment without car, then non-employment with car, and non-employment without car, retired with car, and retired without car. So here what we try to show is that demand calibration is not only by the mode or demand segment. Here you can go by person group as well. But it's limited to certain thing. So here in this case, so it requires Visum 4-step and logic choice model. So the next second part of Visum improvement, which we have included in Visum 2021, is the visualization. So the focus is more on an activity profile and SBA vehicles. So the new view, the activity profile. The activity profile follow a generic concept. Okay. So this is more for demand calculation. I think some of you, which we know that in Visum we have a standard 4-step model and the activity demand base. So for the activity profile, so the activity are displayed on a time axis. So concurrent activities are stacked up on top of each other. Activities can be classified by any attribute. Activities can be filtered by reference object. Limit the activities by filter formulas. Addition, disaggregate view, and synchronization. So in this case, the users can see how the activities are activities are from home to work can be rearranged. Let's say home if the trip is starting from home, then stopping at a shopping, then the destination is to work. So this can be rearranged and can be displayed in Visum. So example, okay, then the ride sharing. So in this case, for the ride sharing trip, okay, ride sharing trip we can in the 2021 Visum 2021 visualization of ride sharing tour legs, number of vehicles in service over time, network-wide assessment, utilization of vehicle, color coded by occupancy. So you can see how that you can display all this information in a temporal distribution. So just to see, okay, on which part which location where there's more than 4 passengers, or less than 4. So then as a planner that you can identify which are the location where there's a lacking of demand, then further checking or analysis can be, or investigation can be done. So for ABM, activity-based management activity, so the visualization of ABM activities, specific location, occupancy of a location, duration and synchronization of single activities. So this does just to show number of people are traveling, to work, shopping, then other activities, and what time they travel. So all this output which you can visualize previously in Visum 2020, that all these are in a table format. If you go to list, then public transport, then you will see in a table, but now this can be visualized in a graph. And line blocking. So for public transport planning, so previously similar. This is more of in a very tabular or table format. Now PTV has improved and put it into more graphical features. So for line blocking, visualization of line block items, amount of buses to operate a timetable, classified by journey, layover, specific to charging depot, where you can define number of charging station needed or visualize the charging power needed. So the last one for Visum in where the improvement in visualization. So for simulation-based assignment, it just shows previously it shows it's more of like the color classification. In a color classification in Visum. So a good example is the volume capacity ratio where the bottlenecks. But now it has been a big change. So the improvement which we made is we can see when you with the SPA and the visualization output, you can see agent-based simulation. So to like the motivation for that is to better understand the assignment result, to identify network coding issue, to support calibration efforts, and to present SPA result. So it's more animation rather than it's just a color classification. I'll show you a video. So now in Visum 2021, the SPA assignment result can be viewed where you can that the user can see the vehicle movement, but this is more of an agent-based simulation. So the darker the color is, then it shows that there's a bottleneck or there's some issue with the network. This is a big significant improvement which PTV has made. Now, again, for the last two years, there's a feedback which we got from the users. Then, like this is I think the significant improvement made for the SPA analysis. Yeah. So this is for Visum. Then for Vistro. For Vistro, the highlights for Vistro. So as we know, PTV Vistro is more for analytical tool for traffic impact assessment. So we constantly improve Vistro to make sure that the features are more user friendly, and like it will assist the traffic engineers or the transport planners to utilize Vistro more for TIA studies. So for Vistro 2021, the highlights are, like merging models, model updating, traffic signal control list, stop bar and crosswalk setbacks, visualization of turning red eye, and PTV Visum import improvement. So let me take through. So the first thing which I want to highlight for PTV Vistro, so as per FHA traffic tool categories, okay, it's a US traffic road authority. PTV products are like accepted for different level of traffic modeling. So for sketch tool, okay, they have a different level of traffic modeling. For sketch tool, travel demand, deterministic HCM tool, traffic optimization, macro simulation, meso simulation, and micro simulation. For sketch tool level, Vistro are widely used. For travel demand, Visum is used. For deterministic highway capacity tool, Vistro. Traffic optimization, Vistro is accepted. Then macro simulation, Visum. Meso simulation, Visum and Vissim. Micro simulation is Vissim. So where our competitor, they're lacking or couldn't fulfill in some of these requirements. So the next slide, okay. So in Vistro 2021, the focus is more of an urban mobility system concept. The complete system with more integration and with highly applicable to large agency, bridge the gap between the traffic ops and planning teams. PTV Vistro is a lower cost foot in the door for the agency. With PTV offline product, so as we always promote that like we have an integrated software for at a different level of modeling level, Visum, Vissim, and Vistro. So all these three platforms can talk to each other, and then this like is a foundation for urban for the plan future urban mobility system planning. So how does the urban mobility system work to connect our products? So in this case, so initially it's like just a travel demand model. So then OSM, OpenStreetMap. Then these are the input data, GTFS or other transit data than big data providers. So all this can be put into Visum, which can act as a transportation database. So once the input data and the travel demand model in Visum then the further expansion. So at the same time, with some of these features of urban mobility system, traffic counts and signal data in Vistro, okay, can be put into Visum or can be utilized if, let's say, the information is already in Visum, can be used for Visum for Vistro analysis. So if, let's say, if any agency using existing synchro or network, so this can be, automatically import into Visum. Then the third is OpenStreetMap. Previously, with OpenStreetMap that you can, create a Visum network automatically. But with the Vistro 2021, we can create the Vistro network using OSM map. So then the last one is day-to-day workflow in Vistro. So Visum and Vistro can read can read or talk to each other, and the process can be can be passed back and forth. So as the title, so as the statement here, PTV Vistro role here is provide engineering details to the system. So again here in this section, I'm going to say what are the features which have been expanded or improved. So with Vistro 2021, there's a new function called model merging example. So you can have if you have more than one Vistro network, you can merge together. So then you can get a bigger model. If in another way is, if you do have if you're using synchro, so then you can bring few synchro models and merge together in Vistro. So this is the example here, model 1 and model 2, then it can be merged into one. So you can see there's a two set of traffic corridor in a separate model. If let's say the agency require these two models to be merged together, it can be done in a click of a button. Then model updating. Updating base model scenario data like signal timing, geometry, lane configuration, or volume. Useful for updating peak period, time of day information, or updating base model data from a test scenario. So with the model updating feature, enables you to convert an external numerous to a base model file into one managed PTV Vistro utilizing scenario management. So in model updating features, then you can import the turn volumes, the signal timing from a different model into a new model. So you don't need to do all this copy paste. It's just you can see that all this checkbox that if you want to just import the signal timing or geometry or turn volumes, then just a click or button that you can import directly into your new model. So for model updating, it includes traffic signal control traffic signal control summary to list and edit traffic signal control ID numbers. Manage your traffic signal controllers with editable description field. Provide detail about the signals, controller like manufacturer type, and last inspection of date. So under these features, that you can create a traffic signal control database in Vistro. so that like you can do a traffic analysis at the same time you can manage all a city-wide traffic signal control information in PTV Visum platform. So then the stop bar and crosswalk setbacks. The location of the crosswalk and the stop bar can be modified with a positive and negative setback. So it enables you to size intersection, size width for visualization, optimization, and setback to transfer to PTV Visum for accurate microsimulation. This is more of, like I think some countries where the pedestrians are quite disciplined. They stop before the stop bar. Occasionally, some country or like sometimes the pedestrians tend to step beyond the stop bar. So this we can give what are the percentage of people are standing before the stop bar and standing after the stop bar. So this can give more accurate for the pedestrian crossing time. Okay. Then the second one is the turning radii. You can draw actually in Vistro that you can exactly put in what is the turning radii of the left turn of each at each approach or each junction. So turning radii input are now visualized in PTV Visum 2021 to show realistic condition at the intersection. So it's previously we used to like based on a Google map or background map. But now if you do know exactly what is a turning radii, then you can define then this radii input are also utilized in HCM 6th edition multimodal calculation. So because in Vistro we use HCM and the turning the radii input is one of this delay calculation. Yeah, so it means that Vistro result gives more accurate. Radii dimension entered in PTV Vistro will transfer to Vissim for accurate microsimulation and sizing of intersection width for visualization and better optimization. So the last improvement for Vistro 2021 is PTV Visum import improvement. Previously, when you have the model, you have a Vistro model, you export to Vissim, then in Vissim you still need to do some tidy up work or clean up work. But now this has been minimized. So update position like a stop bar, crosswalk, radii, maintains the exact coordinate location in Vissim and correctly size the intersection and the node structure. So this is what I meant. So with the current or the previous version, when you export your network from Vistro to Vissim, then you still need to do some minor adjustments, but now this has been minimized. So then the third Vissim improvement which has been improved is enables you to create a powerful 3D out-of-the-box simulation with a click of button directly out of your Vistro 2021 model, resulting in huge time saving. That you no need to create and do the same work in Vissim. So once you have everything you build in Vistro, when you export all the features, the 3D features is in Vissim. So then the another improvement which is included in Vistro 2021 for Vissim import, the interchange detail or the geometry detail. So you can define in Vistro exactly how the interchange or intersection looks like. And once you're happy with the network, you can with the demand you can export to Vissim. So in this case, you can save a lot of time that you do all your analysis, optimization, optimization in Vistro, and to visualize that you can export to Vissim. So that's that's all for like the Vistro 2021 and Visum 2021, the new improvement which PTV has introduced. If you do have question, please contact us. So we have our partner in Taiwan, TMS, then my colleague Yao Yang. So that's all my presentation for today.
Hi, can you hear me?
Yeah, okay.
Okay, so I think I'll stop my video to reduce the bandwidth as well. And I will start sharing my screen. So for Vissim and Viswalk 2021, it is PTV's vehicle and pedestrian simulation software. These are some of the highlights we want to talk about today. So simple ITS tools. It is the inbuilt signal controller actuated program where there is already some done in Vissim 2020, but there's some extension in Vissim 2021, and we'll talk about more of that later. And also parking lot and parking lot groups evaluations, and then on towards the attribute modifications. And we'll talk a bit about the OpenDrive improvements for customers interested in driving simulator interface where you don't want to rebuild the network in Vissim, but straight away import via OpenDrive, and there you have it in Vissim straight away. And then lastly, we will talk about a bit about the Viswalk fire safety improvements. So talking about the simple ITS tools, it is an easy way to simulate intelligent transport systems without the need for Visback or other programming for signal controller. These are available in Vissim already, but now we have some additional buttons in the vertical toolbar and flyouts for comfortable configuration. So the definition of the major flow is now combined with two-phase actuated signal controller, and the pedestrian crossing signal controller has been accessible through the context menu, and now also with its button and a preview of the new object to be placed. Also the railway crossing signal controller with halt and checkout detector. And then lastly, this is the extension in Vissim 2021 for RAM metering controller. So this is based on the linear algorithm. So now I will quickly go to Vissim and let me know if there's any issue to see Vissim in my desktop. So if you see here, what we have is a pedestrian walkway, and then with the vehicle link as well. And this is the beta version of Vissim 2021. And you see there are these new tools in the vertical toolbar now. And if I click on this create pedestrian crossing, if I just hover on this pedestrian crossing, I can have a preview of what it looks like, and I'm happy with this, and then I can click OK. And what happens is that it kind of replicates the push button effect, where when there's pedestrian detected on the detector, then the signal state changes for the pedestrian. So another similar concept will be for the two-phase actuated signal controller. So this is based on the major flow and the minor flow. So if I click on this one and I say I want to create the two-stage signal controller, and first I define the major flow, and then over here I click on the junction, and I again see a preview, and it is exactly what I want as well, where there is the actuation on the minor load, which changes the signal head for the major load, and once that is done, I click OK. So in this beta version, the toolbar for the railway crossing is still under development and under review. So what I did here was already creating a railway crossing here, and this is based on the check-in and check-out. So when the train is detected over here, then the signal controller starts changing, and then when it checks out after, then it changes back. And again, we will go to the newest one, which is the RAM metering. And for this one, you can again select straight from the toolbar, and then you put it on the on-ramp, and then the detectors on the major road. And then these attributes as well are changeable by the user, but now we use the default. And once that is done, you can quickly see that how these actuated controllers are created. I go back to the 3D mode and I play the simulation. And what you can see here is only when pedestrians are detected, then the signal changes for them. Similar concept as well for the vehicles on the minor road. Only when they are detected, the signal changes as well. And over here, I think, let me just quickly go straight to second 300 when the tram is supposed to enter the network. And over here, you see that once it gets detected over here, then it just gets green until it goes through the all-out detector. So this is what we wanted to kind of show from the simple ITS tools inbuilt now in Vissim. And I will go back to the presentation. All right, so that was a preview of the simple ITS tools in Vissim 2021. Going next into parking evaluations. So at first, a little explanation. So in Vissim, there are the individual parking spaces, and many parking spaces can be grouped into a single parking lot, and parking lot groups can encompass a few parking lots over here. And in the old parking lot dialog, you can find for dynamic assignment tab, it's called the attribute group. In Vissim 21, we have changed it to destination group to better represent the meaning behind for dynamic assignment. And for evaluation group, we have a new attribute that is used for parking evaluations. Now you can find it in the list only, but after the release, it will soon appear in the dialog as well. So the new parking evaluations are available for individual parking spaces, parking lots, parking lot groups, and even for parking routing decisions. And on the right side, you can see that there are these new parking states available, including when vehicles are blocked while leaving a parking space or when they are back to their main route and driving to parking space as well. So what do you get from these new evaluations? Many evaluations for individual parking spaces, lots and lot groups, like number of vehicles entering, number of vehicles parked, the occupancy rate, the parking duration, and many more. And on the right here, you can see for parking routing decisions, there are the extra evaluation output as well. And as usual, when there are evaluation output for graphic analysis, there is an improvement as well. So if you see here under edit color scheme, you can have color scheme for individual parking lots, like what you see over here. And if they are, for individual parking spaces, and then for parking lots making up many parking spaces as well, then you can have uniform color across, or even for parking lot groups encompassing many parking lots. And for individual vehicles, you can now color them based on the new parking state over here. So this is the look into the new parking evaluations output and the graphical analysis. For the next one is an interesting update, which is the attribute modifications. So now it is possible to model formulas that can access old values from the last time step and calculate new value based on the old one. So then cumulative calculation is possible. Essentially, attributes can be edited during simulation run, and this actually reduces the need of scripting, where header and text editor is not necessary in Vissim itself. So there are some changes in the menu button, where in previous versions, it is called scripts. Now there are actions, and under actions, there are the old features, which are the event-based scripts and run script file. Now there is a new one called attribute modifications. And what you can see here is you can target the object type and the object type attribute, and then similar to what we have formulas for the user-defined attributes and also formula routing, here you can define formulas as well. So again, I will quickly go into a model in Vissim 21. All right, let me know if you can't see the model or if there's any issue when I play the simulation. So, okay, this is based on an old model, but there is some modification done to basically include the attribute modifications. And what happens here is we want to do the movement control for the barrier and to generate pedestrians going into the hotel, which is done here. And if you remember in the old example, previously there were two scripts done. So one script is to basically control the barrier movement, and another script is to generate pedestrians. But now if I go under actions, event-based scripts, you can see that there are no more scripts there. But instead, under attribute modifications, what we have done here is that there is the object type name that we want to change. This is where the barrier is, and we want to change the state of it. And if I open the formula, it's based on the if condition where if the signal state of the particular barrier, later we will show how the signal state is linked, equals to a particular number, and the barrier state is less than the total number of barrier states minus 1, then we change the barrier state plus 1. If not, we remain as it is. And there's another nested if condition where if the signal state not equals to 1 and the barrier state is above 0, we change the barrier state minus 1. And if not, again, remain as it is. And if I go into 2D mode for better explanation, what you can see here is there's a signal head connected, and based on this signal head, the barrier moves based on our attribute modifications we define here. And as you can see here, there is detectors before and after. And if I go under signal controller, this is based on the ITS tool, and this is based on the railway crossing. And even though it states railway here, you can see that this is a great use case as well, where you can get a check-in and check-out detector, and based on that, the signal hits changes. And what is worth mentioning as well is that how the pedestrians are generated if you don't want to write a script to generate pedestrians. What is done here is they are operating on public transport line over here. So this is a bit of the introduction to attribute modification. So if you download our beta version now, this example is already in there if you want to check out more of the formulas and more information that you want to gather. And again, I will go back to this slide. All right, so next we will go into the OpenDrive improvements, and mostly for our customers interested in driving simulator interface, where you want to quickly import an OpenDrive network that was done in another software, for example, VTD for autonomous vehicle testing. All right, so now we have the OpenDrive improvements, and we support version above 1.4, and there is an improvement of lane widths, where if the OpenDrive link is of different lane widths, what is done when it's imported into Vissim is where connectors with short lane each at the start and at the end are created. And as you know, in Vissim, connectors then can have variation in the lane widths. And also there's the improvement of the elevation profile for links and connectors as well. And also COM access to import OpenDrive functionality. And for the next feature, this is an extension as well of the 3D buildings that can be shown. And this is where we can show and hide the 3D buildings. And I think as well this can be further explained in Vissim, so I will show in Vissim as well. Alright, so over here is just an example from the Mines example, and if I want to show the map box buildings, I can just click on this. And what you see here is this building surrounding your network. And now there's under context menu a new button called Edit Building Visibility. And if I select here and I say that, okay, I don't want these buildings particularly over here, and I click Control to select them all, and I tick it, then they disappear. And another thing worth mentioning is if you want to select a whole area to disappear as well, what you can do is just drag the whole area and then click Enter, and that's done. And again, if you want to, again, show them up again, then I will just click on Visible and they appear again. And what is worth mentioning here is that if I have a static 3D model, for example, over here I choose a supermarket, and basically if I have a static 3D model that is overlapping with the 3D buildings, what happens is that your static 3D model will stay and the buildings will disappear. So there is no such a double layer of the building configuration. Alright, so that is all I wanted to share about showing and hiding 3D buildings. And again, going back to the presentation. So for custom lane change behavior, there is an improvement to if you create the exact user-defined attributes called smooth lane change, and it contains number of free distribution. This is used as the cause of change of the lateral position of the front edge when they are changing lanes. And if you add another user-defined attributes for driving behavior, exactly called the lane change duration, this value is used as duration of the curved lane change. Otherwise, you will follow the fixed value of 3.6 seconds. Remember that normal lane changes still take 3 seconds. So if you see in this graph over here, what happens is that by default, then this is the orange line here. But if you want to add in a curved lane change duration, for example, the blue line here, then that is what you can modify for your driving behavior. And just to mention some drawbacks, that it costs 4% of performance. And as you, and of course, like it does not work correctly with any other desired lateral position other than the middle desired lateral position. And right now, there is still no check of sensors and dangerous input yet. For the next one, which is the multi-run changes to video and animation recording. In the past, you cannot define the recording scope, where it will be recorded for every run, but now you can define an extended recording scope for first run and or final run only. And another improvement is for the speed up simulation of even 5 to 15% for bigger networks and even up to 25% as well. And now we want to give you a glimpse of Vissim AR. So this is another interesting improvement here, where Vissim AR is easy to use and accessible app, and it promotes interaction and collaboration, where instead of just showing videos or your modeling simulation, you can show it on an AR platform for authorities and for customers to see. And here is based on the downtown Singapore case study, where there are 2 scenarios, where one scenario on the left is based on no CAVs, no connected autonomous vehicle, and the case study on the right, the scenario on the right, is based on 100% of CAVs in the network. And as you can see, this button here, this middle line here, you can swipe between the 2 scenarios to quickly output, even to see the speed, the density, the volume, and even the individual vehicles in the network. And maybe I will quickly go through it a bit since we are a bit limited on time. You can see that if you zoom in as well, and then you can swipe between the two scenarios as well. So this is kind of what we wanted to show for this Vissim AR, which is a new feature, which is a new addition to Vissim. And for the next slide, we will go into Viswalk specific features. So for the attributes of desired speed factor at areas, ramps, and pedestrian links, these can now be modified during a simulation run. And for individual pedestrian attribute, there is also a desired speed factor as well, which can also be modified during a simulation run. And for beam import, there are now the possibility to import more complex staircases, and there are also improvements for the CAT and DWG import as well. And lastly, new relations from pedestrians to static routes and partial routes. So if a pedestrian is on a route, then this relation is set. Otherwise, it is empty, example, when pedestrians are boarding a public transport vehicle. So for the integration of Viswalk with FDS, which is the Fire Dynamic Simulator, which is a third-party software, this was done in Vissim 2020 for fire visualization and FET and FIC computation. So this video is just a refresher of what was done. And to mention as well, this is based on the REMIA test case that's available in the example. And of course, the simulation output visualization is much better if you have smaller time steps in between as well. So if I quickly go through this video as well, just to show you a bit of the visualization of the burning of the chair starting, and then how people are evacuated. And then you can see that based on the FIC output attribute, we can color pedestrians based on that to kind of see how exposed they are to all these irritants and all this concentration and dose as well. So for the fractional effective dose again, and how pedestrians are evacuating the building. And as usual, you can always allocate color scheme on areas based on density and other attributes as well. And then for pedestrians in the network, you can color them based on the experience density. So again, the coloration of different, let's say, outputs of the 3D plot can be done and is based on your skill and your coloration to define very easily in Viswalk. And so this is displaying the extinction coefficient. And this is, let's say, displaying the carbon monoxide, and then the HCI, and for the suite as well. So various FDS output that you can simulate for visualization in Viswalk and for the FET and FIC computation. So going to the next slide for the new Viswalk fire safety improvements. So when safety engineers perform an assessment of life safety in case of building fire, they usually compare the available safe egress time, which is the ASAT in the map graph here, and the required safe egress time. So while ASAT focuses on fire, RSAT focuses on the occupants. And the analysis of both ASAT and RSAT are conducted based on the basis of maps. So if you subtract RSAT from ASAT, what you get is this difference map that you can see here, and then a sort of safety margin throughout the entire floor plan. So ASAT describes the performance of a built environment in terms of resistance against consequences of fire. So this is achieved by determining the time when tenability criteria of fire effects are exceeded. So this part of ASAT is not calculated in Viswalk, But on the other hand, RSAT captures the occupant's address out of the building, and so this can be calculated in Viswalk now. So as mentioned, RSAT map is a map representing the spatial distribution of required safe egress time, and it provides comprehensive information about evacuation dynamics of the scenario. So the routine determines the time when a cell has been traversed by an agent for the last time. So the corresponding grid then is set to this particular time that you can see over here in the RSAT map. So if a grid element has not been traversed at all, it will remain not a number, which is what you see here, which is the NAN. So some of the output visualization that you can see from the RSAT map can be seen here, where you can have a full overview of a building RSAT map. And just to show you how it looks like in the output attribute, where there is a new result attribute of RSAT, and this attribute contains latest simulation time in the time interval, where at least one pedestrian was inside that grid cell, and it can be used for color schemes for areas, ramps, and staircases. And if you want to look into more of the theory and details behind ASAT and RSAT, you can check out these links over here in the slide at the bottom. All right, so that is our overview of the new Vissim and Viswalk features. For the next slide, we just want to highlight that there are many webinar programs, especially this year, that are online and they are free, and you can simply register based on the topic of interest, and also our ever-expanding webinar archive of Visum, Vissim, Viswalk, and Vistro as well. And just to mention some key webinars and PTV talks, which are the Vistro talk and the common programming in Vissim, and the Vissim dynamic assignment, Visum OD matrix estimation, and the Viswalk comparison to real world. So all this, you can check out the links, and they are recorded, and you can go look into these webinars as well. And there's a very exciting webinar coming up on September 16, 2020. It's called PTV Traffic Simulation for Automotive 2020. Definitely register if you're interested, and we look forward to seeing you in the event. And